In this lesson, we're going to go over characterizing data. Specifically, we'll discuss the properties of a distribution of data, and we'll learn to calculate and interpret central measures of a distribution. So distributions of data. So the distribution of a variable refers to the way its values are spread out over all possible values, and the way to display this is using a table or a graph. So notice this graph here displays the height in feet of black cherry trees and how often those values occur. So for instance, there are probably about 3 trees that are 60 to 65 feet high, 3 trees that are 65 to 70 feet high, about 8 trees that are 70 to 75 feet high, 10 trees that are 75 to 80 feet high, okay, and then so on and so forth. If you draw a curve to kind of estimate what's going on here, well, I drew it a little off, but notice that the peak of the curve is usually where the mode or the highest concentration of values are. Measures of center in a distribution. So as a quick review, the mean is what we most call the average. And to calculate the mean, you add up all the values and divide by the total number that you have. The median is the middle in a sorted data set. So typically you sort it lowest to highest and find out the middle value. If there's 2 in the middle, you take the halfway point between those two or add them up and divide by 2. And the mode is the most common value or group of values in a distribution. So an example, 8 grocery stores sell the PR Energy bar for the following prices. So the prices are listed here for you, and notice that the set is already ordered smallest to largest for you. Okay, so that's something to take note of, whether it's in my math lab or something in Canvas. Check before you start putting in the work to see if your set is already lowest to highest. Okay. So the solution is on this next slide. So with the mean, you add up all the values and divide by 8. These parentheses are really important for the Texas Instruments calculator. If you don't put those there, all the calculator is going to do is divide your last value by 8. Okay, so add them all up, maybe hit enter, and then divide by 8. So the mean price is $1.41. The median, so you list your values out, and usually I take my fingers and I go down. In this case, they're crossed out. There's 2 in the middle. So take the halfway point between these 2 middle values. The way to calculate this is to do 1.35 plus 1.39 and divide by 2. And so this value here, the $1.37, is the median. And then the mode, the value that occurs most often. Outliers. So outliers in a data set is the value that is much higher or much lower. So an outlier could be way off in the greater end of things, or too small and everything else is higher. Okay. It usually, or it does affect the mean, but generally doesn't affect the median or the mode. So take a look at the example with contract offers. $0, $0, $0, $0, $10 million. So if you were to calculate the average or the mean, you would take 0 plus 0 plus 0 plus 0 plus 10 million and divide by 5 and get an average of 2 million. That might not be the greatest representation, but notice how the outlier of 10 million is pulling the average towards it. So in a display, and we'll talk about this when we deal with skewness next, is that your outlier can pull the mean higher if your outlier is a bigger value, or it can pull the mean lower if your outlier is a smaller value. Symmetry and skewness. So these are ways to describe a distribution of a data set. A single peak is symmetric if its left half is a mirror of its right half. So visualizing this, oops, I should choose a brighter color. Something like this, where if you draw a line down the middle, the left half looks the same as the right half. A single peak distribution is left skewed if its values are more spread out on the left side of the mode. So remember that the mode defines where our peak is. So let me draw this graph. So if the data values are more spread out over the left side of the mode, we get something like this yellow line here. Okay? And then a single peak distribution is right skewed if its values are more spread out on the right side of the mode, so going the other way. Okay? So notice our little skunk here. Skew corresponds to the tail of the data set. So for instance, in our left skewed data, our outliers would be lower values. Okay, and those values are more spread out. In our right skewed data set, our tail is on the right hand side and our outliers are bigger values. So some scenarios. So for each of the following situations, state whether you expect the distribution to be symmetric, left skewed, or right skewed. So what I like to do for these ones is I would draw the 3 possibilities, either symmetric, left skewed, or right skewed, and then think about it in terms of outliers or where the tail would be or what the graph means. So heights of a sample of 100 women, do we think it's symmetric, right skewed, or left skewed? Okay. So typically if you have 100 women, it's probably going to be pretty symmetric. The heights would fall in this middle category here, and there would be some taller and some shorter, but maybe not too many outliers to pull the mean in one direction or the other. Number of books read during the school year by fifth graders. So if you're taking a look at these values, fifth graders typically read what's assigned, and then maybe some students really like to read. And so your outliers would be higher number of books read. So if we graph this out, okay, you're probably going to have a right skewed set where the outliers are going to be students that read way more than they're supposed to, which is a great thing. But in terms of the distribution, it would probably make it a right skewed distribution. Part C, number of gifts purchased for the holiday season over the course of a year. So we have January, February, March, April, May, June, July, August, September, October, November, December. So our graph is probably going to go like this because with the kickoff of Prime Day being in October or Black Friday, a lot of shopping occurs during the later months of the year. So this is an example where our data set would be left skewed. Okay. Some people buy presents or gifts all year long, but typically you see the higher concentration of sales towards the end of the year. Okay, and so the examples are listed here for you on the previous slide. I just wanted to demonstrate one way to maybe think about those, or a couple different ways. Think about it in terms of where the outliers are. Are the outliers going to be high or low? And that determines the skew. Or since I'm more visual, I like to actually draw a picture, label it, and then go from there. So skewness and measures of central tendency. So how does our skewness relate to mean, median, and mode? So since outliers have a greater effect on the mean, remember it only really affects the mean, not really the median or the mode. The skewness of a distribution is determined by looking at the values of the mean and the median. Okay, so for instance, on this side here where we have a left skewed data set, our outliers are the low values. Our mean is closer to those because the outlier is pulling it. Our median, and then our mode is where the peak is located. So when the mean is less than the median, the distribution is left skewed. Now look at our right skewed set. Our outliers are high values. Our mean is always going to be closer to those outliers, okay, because the outliers pull the mean towards it. Then we have our median and our mode. So when the mean is greater than the median, the distribution is right skewed. And you can see that our median is located here and our mean would be a lower value. Okay. So example 3, dealing with skewness. So taking the mean and the median of a data set, you can usually determine how the data would be skewed. So for the following situation, state whether you expect the distribution to be symmetric, left skewed, or right skewed. So scores for a math exam that have a median of 72 and a median of 81. So what I would do is I would first draw this out. I'm just going to put 72 and 81 here. Here's our mean and here's our median. If our mean is less than our median, that means our data, this is going to be left skewed. Okay? I typically remember it as the outliers are closer to the median because the outliers are pulling it. So our outliers would be here, which means that the data values are more spread out. Okay, so looking at this graph as well, we can also interpret it to mean that majority of students did pretty well. Yes, as a whole, students perform well on the exam. Okay, thank you for watching. If you have any questions, please feel free to reach out to me.